So, I get to be the last one to say this. Welcome back, faculty, staff, returning students, and welcome to students of the class of 2020. We've heard over and over in speeches like this that you should work hard and be dedicated, and you should. But at the end of this is success. Encouraging you to succeed is one of the things I'm supposed to do as a teacher and a mentor. Today, I'd like to encourage you to do a much, much harder thing. I want to encourage you to fail. You need more? Is that okay. I think the value of success is pretty obvious. I think the value of failure is often overlooked. All of us, students, staff, faculty, tell us that the reason we're here at Bennington is that we've been successful in what we set out to do. Students, you worked hard in high school, you wrote a convincing essay about why you should be here, and you were successful, you're here. Now that you're here, I want you to have the courage to fail. A few weeks ago, I saw an inspirational video that has made the rounds on social media about the power of overcoming failure. It's a few years old, you've probably seen it. It's J.K. Rowling, and she's talking about failing at everything she ever did, and that failure pushing her to do the one thing she was truly great at. It pushed her to write. She suggests that without failure, and these are her words, stripping away the inessential, she would have never written Harry Potter. It's an inspiring story, and I think on some level, though, it sells short the power of failure. It posits that failure is something to overcome. That failure is something that pushes you away from the things you're supposed to be doing towards the one true thing that you are supposed to be doing. That by trying something and failing, you learn that your true skills and passions lie elsewhere. I don't think Rowling is entirely wrong. It's one way to deal with failure, to take it as a check against what you're supposed to be doing. But I don't think it's the most interesting way to think about it. Failing at something does not necessarily tell you you're no good at it. It doesn't even have to tell you were doing anything wrong. Albert Michelson and Edward Morley were physicists in the late 19th century at Case Western Reserve in Ohio. They conducted this experiment that was one of the most well-known and perhaps successful failures in the history of physics. One of the things we understand about how waves move, and have understood for a long time before Michelson and Morley, is that waves move through a medium. So sound waves, the sound waves that are coming to you right now, are moving through air. Water waves move through water. Excellent. So by the late 19th century, scientists realized that light showed some very wave-like properties, so the light that's coming to you right now. And they thought a reasonable experiment was to try to figure out the medium through which light traveled. Scientists called this medium, which I just have to point out they had yet to discover but had still named, they called this medium ether. Michelson and Morley set out to characterize the ether with a particularly clever and simple experiment. That's the best experiments in science, those that are simple. Without getting into the details, I'll just tell you that the detection failed. They were unable to detect the ether, much less measure anything about it. We now know that their failure was one of the gateways to modern physics. We now understand that light is fundamentally different from other waves. Light is both a particle and a wave and doesn't need a medium through which to travel. It's really weird. There's no ether, though, and they failed at detecting it because it wasn't there. In my own field of astronomy, there's a much more recent example of this type of failure. One of the big projects of the last part of the 20th century was an experiment undertaken to measure the expansion rate of the universe. We've known since the 1920s that the universe was expanding, but as we developed better telescopes and better cameras, not me, I wasn't around in the 1920s, we started to measure with high precision exactly how fast it was expanding. At the time the experiment was undertaken in the 1990s, before all of you were born, it was well understood that all the matter in the universe, so the sun, the moon, Earth, you, me, the podium, this thing, which terrifies me slightly, that this was going to slow the expansion of the universe. So it's like you throw a ball up in the air, and at some point the ball reaches the top of how far it goes, and then it comes back down to Earth. And so the question is, so this stuff was going to slow the expansion of the universe and perhaps cause everything to reverse direction and crunch together. So the questions they were trying to answer is, was there enough stuff to stop the expansion? And when was this going to happen? So at the end of 1997, the head of one of the teams studying the expansion, an astronomer named Adam Rees, was looking at his data. The data his team had gathered were measurements taken of a large number of dying stars called supernovae that had exploded a long time ago in a galaxy far, far away. There's actually several galaxies, but it messes up the line. Anyway, so the problem that Rees saw was that these explosions were closer than they should have been. There was no way that the current theory of the universe could explain them. In the end, the only thing that convinced Rees that he should publish his results were hearing a rumor that one of his competing teams had identical results they were planning on publishing. The two teams published their results at the same time in 1998. What they discovered was the universe was not slowing down in its expansion, but rather speeding up, accelerating. It's as if you tossed the ball up in the air, and instead of stopping and coming back to Earth, it sped up as it went higher up. So all the stuff in the universe had slowed the expansion for a time, but something was causing it to speed up. The two teams discovered something that we today call dark energy, and we still really do not understand. So Michelson and Morley failed to detect the ether because it wasn't there. Astronomers failed to detect the universe slowing down because they discovered something new, dark energy. I think this is a form of failure that at some level we're all comfortable with, and many of us are familiar with. Heading down a path we think is going to lead in one direction, and then finding something we didn't expect at the end. These stories are nominally about failure, but more about how challenging it can be to recognize success at times. So what about people who truly got it wrong? Two great scientists of the 20th century repeatedly failed at what they were trying to do. One of them, the prominent astronomer Fritz Zwicky, that's a great name. He's prominent among astronomers, but probably not well known to most of you. The second is a former Swiss patent clerk. He's well enough known that I can just call him a former Swiss patent clerk, and many of you know to whom I'm referring. So Fritz Zwicky, was a wonderful example who brilliantly and tremendously failed. He was an incredibly gifted observational astronomer. However, his interpretations of his observations were often well outside the mainstream, let's just say. He saw things in his images that most of his contemporaries didn't. And he was not shy about telling his colleagues what he thought of them. There's this great amalgam of Zwicky quotes on Wikipedia, so just read them. Zwicky described his colleagues as scatterbrains, sycophants and plain thieves who, quote, have no love for any of the lone wolves who are not fawners and apple polishers, and who quote, doctor their observational data to hide their shortcomings, and to make the majority of the astronomers accept and believe in some of their most prejudicial and erroneous presentations and interpretations of fact, and who, therefore, publish useless trash in the bulging astronomical journals. He must have been a real treat. He also was fond of describing some of his colleagues as spherical bastards, which he defined as a bastard no matter which way you look at them. Don't do it now, but after, do Google Fritz Zwicky, and there's a great picture of him sort of scowling at the spherical bastard. So anyway, so why wasn't he just ignored? Well, because he was occasionally right, sometimes spectacularly so. He was known as one of the initial discoverers of dark matter, which makes up 85% of the mass of the universe. And he was such a gifted observer that even when he was wrong, he made everyone's arguments sharper by forcing them to disprove his theories. So how about that Swiss patent clerk? Albert Einstein is the genius prototype. He developed relativity, one of the cornerstones of modern physics. But for the last 30 years of his life, he grappled with another cornerstone, quantum mechanics, never quite fully accepting it. He found quantum mechanics so deeply weird that he just couldn't accept it. He found the probabilistic nature of quantum mechanics anathema to what physics was supposed to be. Where Newtonian physics and Einstein's relativity talked about the motion of things, quantum mechanics suggested that our handle on those things was less firm than believed. In one way, Einstein was right. Quantum mechanics is deeply weird. However, his attempts to disprove the theory failed because he was just wrong about the theory being wrong. But much like Zwicky, his failure to recognize quantum mechanics with relativity kept pushing the field forward and brought out the best in the scientists with whom he debated. Sometimes, though, we fail because we don't yet have enough experience to recognize success. I had a student a few years back, a wonderful student who was adventurous, creative, and hardworking. As a final project in one of my classes, he decided he wanted to measure the speed of light. He set up an experiment where he bounced a laser between Dickinson and Jennings. Even with a relatively large distance between the two buildings, it still takes a pulse of light only 3 microseconds to complete a round trip. Despite the incredible technical challenges in measuring that minuscule passage of time, the student measured the speed of light within a factor of about 50%. This is incredibly impressive, just to be clear. He viewed this as a failure. Why? He only thought a more precise measurement would be good enough for what he wanted. He didn't have the experience to realize that he had coaxed something incredible out of the measuring equipment. He thought he had failed, when in reality, he had succeeded beyond what was expected. Sometimes we have to be okay with failing because we don't yet know what success looks like. Okay, so time to conclude. I've cheated a little in the stories I've told you. Even though I've cast them all as failure, they were in the end successes in some way or another. The search for ether and the discovery of distant supernovae opened a new world for us and taught us fundamental things about how the universe is put together. Fritz Zwicky and Albert Einstein seriously advanced the dialogue and pushed others to do great work. My student had successes masquerading as failures because he didn't yet know what to look for. Also be willing to accept a more pure, more mundane failure. These failures are rarely discussed because we don't think they're interesting. I don't have any cute stories of the type of failure that is so commonplace in the work that we all do. It is not just unsuccessful people who fail. It is not just people who don't know what they're doing, who don't know how to create a sculpture, or write a play or short story, or set up an experiment, or any of the hundreds of creative endeavors that take place on this campus every day that all of us are here. It is not because we are bad at our job that we fail. It is because, at the beginning of any ambitious work, it is nearly always impossible to tell the difference between work that will succeed and work that will fail. This happens to everyone on this campus. But one of the things that improves with experience is having some ability to spot failure from a distance, to know which paths are less likely to lead to success. In some way, one of the reasons that faculty seem smarter than the students is that they failed over and over and over again in ways that the students can't even imagine yet. An important thing, I don't want you to confuse my message of fail with don't try. You might think that if you're going to fail, why bother trying, right? The mandate I'm setting you forward with, to fail, is not an excuse to be lazy. It is not an excuse to not do your damnedest to forestall failure. Indeed, while you can't necessarily tell in the beginning of a work whether it will be a success or a failure, the one sure way to turn one of your successes into a failure is through lack of work, by not trying. However, we can't let our fear of failure or memories of past failure keep us from doing the important work that we all will do. Don't do boring, safe work because you're afraid of failure. Finally, I just want to say that Bennington is one hell of a safety net. For those times when you do fail, when you work as hard as you can and you don't get there because you don't have the skills yet, or you took a wrong turn somewhere, or because it was just a bad idea, we're here for you. The faculty, staff, students, especially the students. Make sure that whenever one of us fails, the rest of us say, wonderful, fantastic failure. We can't wait to see what you try next. Thank you.